Um, so yeah, so looking
Just
at
like,
like so feel free to talk or whatever. So looking at the 2022 um, WPILib, like some of what they updated, but also just stuff that like some of it got that it put in 2021 or even 2020, and we just never used it. So it's stuff that we're gonna start using more. And then some of the stuff I've been working on and that we've changed, and just like how code works, some of the stuff we did in 2021 that we haven't really talked about. Um, so new for 2022 exists. So there's a full change log of like what all changed inside of the library in the 2022 beta and what's changed so far. Most of this doesn't actually matter to
apply
us.
those. Yeah.
So like a lot of it is just like a few rename things that you probably didn't know what their names were before, and you were just having autocomplete do it anyway. Things like that. So there's some new stuff. Most of it's not super important. So the things that um, are useful is it has the new Rev control system stuff. So we're gonna get the new um, power distribution hub, pneumatics hub. Those are the two main things. So we'll get those from Rev. So it has code to interact and work with those, which is cool. So as soon as we do that, they made some shuffleboard improvements, which is what we use on top of the driver station as our display and like feedback from the robot, which we rewrote and reorganized a lot of how we do that in code. So that's one of the things we're going to look at tonight, and took advantage of some of the new shuffleboard things, but really it's just like us using old stuff that we hadn't been implementing. There's a new thing called sysid, which replaces FRC characterization, which a few people were around in the summer when we were playing with the Swerve after Texas Cup, when we were trying to get it to do some of the Auton path following, and we were using FRC characterization to do that, and it was super weird and complicated. It needed like a whole it needed like a Python thing that you had to launch, and the
Oh
steps were
no.
very, very difficult to launch everything, and it was really complicated. Now it's pretty easy. So this is the 2022 code. This is the
Mhm.
2022 version of our 2021 robot code. So this is what will go onto Gamma when we're testing 2022 stuff. So now you can just go to Start Tool, you can hit sysid, and it brings up this nice interface thing, and you can basically just like choose which motors you're using, and this allows us to get tuning values that make it really easy to control certain aspects of the robot. So if we're trying to like make an elevator or something, we can do that relatively quickly, or a flywheel if we're trying to change things, and we can get some more. We can understand like how it actually physically works based on the encoder feedback and things, and put those settings into the code, and it'll make it a lot easier to be able to do velocity control and position control on some of those systems if we need to.
So it's kind of like
Um,
a simulation type thing.
so this isn't simulation. So this you have to run. This actually controls the robot. So you have to be next to the robot, and it like actually runs the motor for a certain amount of time, and it reads the encoder values back, and it figures out what these like tuning values are for, and like or it figures out what the numbers are that helps you configure it to make it so it accurately moves to the correct position or accurately gets to the right speed. Um, if you
Oh, okay.
have if we end up not doing swerve, if we end up doing a normal um, tank drive skid steer robot like our 2020 robot is, you can
Yeah.
also do the entire drivetrain that way. So then it makes it really easy to do like the path planning in auto, or makes it easier, not really easy. And definitely don't want to say really easy. Makes it easier to make it do like drive certain arcs and actually get to where we want in autonomous. So if we end up doing that, it works. It doesn't work with swerve right now. The old one kind of did, but it was a little bit weird to get it set up, and this new one basically doesn't at all. Not in any normal way. Like we might have to mechanically lock the swerve modules from being able to rotate if we want to use it or something, because we were able to do some hacks around the old system. That because
What do you
this
mean
one
like
is
mechanically?
like figure out a way to like bolt them in place so they can't steer
Oh,
while we're trying to have the robot drive back and forth. um, which we kind of tried to do last year, but it was weird. There might be some version to do it, or like clamp them in place or something, so that they all are straight, so that we can get just like our straight line headings for it, and then from there we can use some of those values. And if we can't, it's not a big deal. There's other ways to kind of tune it and do things we need. But But this is definitely it's an upgrade for sure over the old system, because the old system was just really hard to use. This should be a lot easier. I haven't done it on a real robot yet, but in general, SysID should help a lot. And if they make it more advanced to where it works with Swerve and stuff, that would be really cool. If not, it's still definitely a benefit over what was there before. What is the other stuff that's in there? So yeah, and then a bunch of small changes we probably won't notice. Beta software is available to download, so it's on the releases page for WPILib. The caveat is that currently this beta 1, if you just install it without anything else, if you've never installed anything else on the computer, or actually even if you have 2021 installed or anything, the simulator won't run. Which we're going to look at the simulator here in a second. So, but you can get it to run if you install the entirety of VS Code 2019 and this like another gig something package for doing C++ development in it. So it's like some of the software they use to make WPILib. And if you get all that installed, then it works, which I had to do to get this to work. But hopefully beta 2 will come out shortly. So then it'll still just be the single easy installer to make the simulator work. So until then, it probably doesn't make too much sense to do it unless you really want to play with the simulator. And we can show you what you have to download to do that. But it's basically the VS Code 2019 and the C++ workload for it. If you install both those things, then it works. But it's another like 2 gigs or so you have to download and install on your computer.
Why 2019 though? Why not like 2020 at least, or 2021?
I don't know exactly what VS Code numbering is. I don't know what the system is. I just know that's what it is. Or that's what I downloaded. Whatever the VS Code installer is and the C++ workload is what you're supposed to get, and it seemed to work at that point. The reason why I was really excited to start playing with this is the thing that we weren't able to do before, and why I was trying to get the simulator to work, is the new CTRE library, which also works with the beta, gives us actual physics sim of Talon FX motors and like the Falcon motors, that Talon FX controllers, which are on the Falcon motors that we used everywhere. So all of the motors on Gamma Ray were Falcons, and we couldn't in 2021 run them through the simulator. They didn't have the software built in to have the simulator stuff work right, and now we do. So it's really cool. So we can come into here, and I can just go simulate robot code, and it'll build. Hopefully I didn't mess anything up to where it'll still build successfully. All right, so it builds. We can just tell it to be the sim GUI. So this is the same kind of way that we start the Romy or anything like that. And now we have the simulator, which is kind of all over the place. Mostly because I just don't have it organized. Let's see. Can make some of these windows be smaller. Okay. That doesn't need to be open. So now we have over here, we have this other devices list, and this list, it's really, really long because we had 15 Falcons, and for every single one of them, it has 4 different little sections. So it has the Talon where you can see like the percent output, so like how much voltage is going to whatever. You can also, it simulates like how much current the motor's pulling. So like if any of your methods or anything are asking stuff from the Falcon, like we used to, like if we have to ask, like the Falcon have the integrated encoders, so they know how far they spin. The simulator is able to ask how far it spun, and it returns an answer. It used to not. It used to just throw a bunch of errors, and it was pretty broken. So now we don't do any of that. It gives us velocity, position, all of that. It also you can simulate the forward and reverse limit switches on them, which we don't really use ever, but they're there. So all 4 of those things exist for every single Falcon. So it's definitely a big, long list. And so you'd have to figure out which one you're looking at all the time, but that's not too difficult. But what's cool is, so Falcon 2 is one of our one of the steering motors, I believe, and Falcon 1 is one of the drive motors. And so here on the field dashboard, so we have this little field widget. We can actually get an estimate of our position from the wheel encoders and everything. And so if I run the autonomous, you'll actually see this little box move in what the path of the autonomous is, which is basically just to like kind of do a little arc thing. So it doesn't move much, but you'll see it. But at the same time, all of the encoders and power voltage and everything to the Falcons are all actually running. So it's giving us an approximation of what the motors would actually see if the robot was actually doing this, all just on our PC. So the big deal and why this is important is we can basically start doing real, more complicated code development without having to be next to a robot. Because the only part that we really need to be with the robot for now, basically from now until forever, is with actual tuning. So if we're trying to make sure the real physics work the way we expect, that's the only part. And like make sure any, like if the motors are inverted or something, if we're not sure which way is forward or backwards, we have to do all of like that normal bring up stuff and just kind of checking how the robot's plugged in and how the actual hardware is configured. You still have to do it with a robot next to you. But for all of like the logic and figuring out if stuff works, even some of the Auton paths, we'll be able to do that fully in simulation, and then be able to tune it and tweak those like different settings when we have a real robot. So we're able to leverage the time we have with the robot so much better than we used to in the past. Because what would happen in the past is we would like go to do something where we're like, okay, we're gonna tune this today. And we didn't have the simulator, so we had no idea if any of the code would work. We'd get there, we'd get everything set up, we'd try to run it on the robot, and pretty quickly we'd find out something was very broken. And depending on how long it took us to figure out how to fix that to where it would even just run at all, our entire like practice tuning session would be over because we didn't have something done correctly. Where now we can be pretty sure something's going to work because we can test it in the simulator as soon as we write it, as soon as we check anything. We can be like, hey, did I do this right? Does it have any runtime errors? Like, are the outputs moving the way I expect them to move? We can see all of that way before we have to put it on the actual robot. It's also a lot safer, right? Because we can check our Auton path in here, and we'll see if this robot, like instead of stopping like it did, if it just kept going, that means that's one less time that the robot just keeps going in real life that we have to like e-stop
Yeah.
it. And now it just stopped. It just like kept going in the simulation. We don't care. Like if it goes in the simulation, like, ooh, I forgot to stop the robot, I should probably go do that. But we can catch it in simulation now instead of on the real robot, which is basically what we always had to do before because we couldn't simulate all of these motors and the simulator just wasn't good enough. Where it got good enough last year, but then we couldn't simulate the motors, so it was complicated. But now it's all exists and it's all pretty easy to do. The values that it's returning aren't perfect. Like I haven't tuned any of the settings. You can go in, I can pull that up too. So you can actually go in and tell it some things about the actual systems. So one of the files we have is called sim. And so in here, we have to tell it which each of our motors are, like where the motors are, and make sure they get added to the physics sim. And then you can tell it the time it takes to accelerate to full speed for that motor and that system. So that's something we could like measure if we wanted to on the robot once we have it working. And you can tell it what the fastest that motor velocity could be. And if you can tell it those two things, now the simulator is going to be a little bit more accurate. So like when you actually tell it to move this right amount of encoder ticks and things will move, you can go through and we can play with how much current the motor's drawing and stuff too if we wanted to have kind of better checks on some of our actual values if we wanted to. And it's definitely not going to be perfect because it's going to act differently than what the real one will do, right? Like none of these currently they don't have real hard stops and things. So some of that we'll have to put in, and we can put in with some of the code to make it work and simulate it better. So like if we have an elevator in here, it would just assume that it could just keep extending the elevator infinitely high, which an actual elevator on a robot can't do. But if there's things we can do to prevent that, and there's things we should have in code that would prevent that anyway, because we shouldn't let the robot go past certain limits of position and everything anyway. Like that should be part of our what we're writing to say like, hey, if the encoder's driven this far, we're probably too far now. We should not let it go any further. So yeah, so that's what I'm most excited about because it's going to be a lot easier to have multiple people writing code and having it somewhat testable. So then they also know when they commit it to GitHub, where we keep all of our shared code, that it's at least workable. Because a lot of times it was always this kind of annoying thing where I'd even for me, if I would like commit something and I never actually was able to test it, I never got to run it through a simulator like this or run it on the robot. I don't like submitting or committing code that is potentially broken. So if somebody else downloads it, try to put it on the robot, it just doesn't work. And that's
Right.
super annoying. So now we should basically never commit code that is that's not running
Broken.
in the simulator properly, right? There's just no, or if you do, like, you can put a big error in like the commit message or something. You can be like, hey, this doesn't work in the simulator. I'm working on something. You can move it to your own branch or whatever, and we'll look at how to do some of that stuff. Those are things that we're going to be able to implement, so we can keep different people working in different aspects better. Just a lot of the integration is nicer now than it was, where we had to do a bunch of stuff by hand that we shouldn't have to do anymore. Um,
I have a question about
yeah,
like the code. Why did you put false at the end of those statements?
put false at the end of those statements.
Yeah,
Let's
like
see.
in robot.
Boolean sensor phase. So it's
Oh,
asking for which sensor phase it is. So it's just true or false whether when we tell the motor to go forward, is the sensor also going forward or is the sensor going backwards? Right. So like if sometimes your sensor might be reversed from your motor, and that would cause things to have a problem. But with the Falcons, it's never reversed, so they're always false because
okay, that makes sense.
they're always true for the Falcon. It's always in phase with the Falcon since it's built in. Okay, so those are the big changes, or this is probably the biggest change. What I was most excited about. Things that I've been playing with, and what some of this is pulled from what developers are doing in 2020 and 2021, but just kind of where we're gonna start in 2022, which is different than where we've done before, is to try to get, now that we have more people who know a little bit, so they haven't actually programmed a competition robot before because we haven't had a lot of competition robots to program
Right,
in the
yeah.
last year and a half. We've had very little. So a lot of people know a little bit, and so a lot of people want to help, which is good. But if we don't organize that well, we're going to be in a mess. And we're trying to avoid that mess. So in all of our past years, our program team's always been relatively small. Some years it's like a student with me like kind of guiding them. Some years it's a couple students. We've had 3 or 4, but it's never really been more than about 4 people doing the majority of it. Um, whether and sometimes I'm more involved, sometimes I'm less involved. It just kind of depends on what students we have, how much experience they have, anything like that. So when we've never really sat and tried to look at how do we get more people involved, like what do we do to make that easier. And so that's part of what I'm trying to do now that we have this opportunity, that we have the 2022 code early enough, and we have the simulator that we can sit and just run. We can make all those changes and know they're going to work very quickly without having to have the robot and like having to swap batteries all the time. Like even when I was developing, I could be alone in the lab, and it would still be annoying because I'd have to like swap batteries and things were actually moving, and it was just way more complicated. It was less safe. It wasn't nearly as nice as just being able to do it in the simulator. So now we can kind of reorganize stuff and play with it a lot more than we used to be able to. Um, so hopefully that's going to be part of it, is where we can figure out what the kind of organization of the robot project looks like, to where we can slice it off easier and be like, okay, you're in charge of either maybe this mechanism, or we have these people working on autonomous, and their stuff can kind of fit where it goes without having to look at necessarily all the code and understand everything about it, right? Because that's where we've kind of been in the past, where if you wanted to do anything, if you didn't understand the entire bit of the software, you were probably going to break something. um, and then somebody would have to come in and fix it, which wasn't necessarily a problem. But if we were like getting close to competition or in the middle of competition, it was never good to do. And we shouldn't be updating coding in the middle of competition anywhere, or not very much. Um, but if we're able to silo it, it's a lot easier for people just to understand a certain part of it, and they can get in, actually help a lot faster than having to understand all of it. Where if we're like, okay, here's how we do subsystems, here's the subsystem you're responsible for. You're responsible for making you're responsible for the code for the intake is what you're responsible for. If they can do that, that's a lot easier than, you need to know everything and then you can kind of work on the intake. So hopefully we can get there. I'm not sure how well that's going to work. We haven't done it before, but we're going to try. Um, So some of the things we did in that regard, or some of the things I've started doing, is we moved. So this folder is 2021. I don't know if I can make. I don't remember how to change the theme in here. I want to make it look different. Nope. Oh, that's the worst. I've done messed up.
Oh no.
Let's try. That's not different enough. I want it different enough so I can flip back and forth between 2022 and 2021 and not make it annoying. Okay, so 2021 is the one that looks gross. So it's the weird brown desert one. So what we used to have and what is the kind of the standard. Oh, nope, can't do that. I will. Never mind. We're gonna spend a couple minutes changing the color until I find something I like. How do people? This is not readable to anybody else, right?
That looks like Python.
This is not readable. How?
Just make it red. Just make it red.
No.
This is interesting.
So you can change the color theme. This is something else you can learn. You can change the color theme. All of them are bad except for the one that is good. Apparently. That's the same one. That's the same one except not with the plus. So dark plus is what I normally use and is the correct, or in my opinion, the correct one.
Wait, is there really a noticeable difference?
Oh my god.
Oh no.
Dark plus adds a few more colors.
Okay.
That's about it. Okay, high contrast isn't terrible. We'll run high contrast. We at least know all the numbers are white. You know we're in the old one.
Yeah.
Okay, so the way we were doing things, and the way if something breaks we might go back to. Probably not. I think I'm done with it. So they introduced WPILib in their like templates and examples. Introduced the concept of a robot container 2 years ago. I think it was in 2020. It might have been in 2019. And I didn't love it then, but I thought I'd give it a try. I knew it was what all the other. It's kind of when it becomes the default. It's what most of the other teams are using. So we need to know kind of how it works. And they reorganized some stuff on their end. So we used it, and we used it for the last couple of years. And it's not terrible. It works. We didn't use it in the same way they did. I'm not even going to go into exactly what they were doing. For anybody on video, they would do what's called dependency injection for all of their subsystems. I never liked that. The people who we had programming never liked that, so we don't do it. I'm not going to explain what it is on here because we don't do it, or not very much. And definitely not for all of our subsystems. So we just make it to where we were just defining all the subsystems in here, and there's a bunch of stuff in here that gets this. Basically, this file became too central to the robot, so it was defining all of our button presses for everything on the gamepads. It also was doing a bunch of like robot initialization stuff. It also included all of our subsystems and like started all of those. And it just had like too much stuff going on. And so what would have happened was if we had too many programmers, a lot of people would have had to been editing in here. And this would have gotten really messy. So I went ahead and removed this in 2022, in the current version of it at least. Now this seems bright, but it's probably fine. So now there's no more robot container. Some of what was in robot container is back into robot, so all of the instances of our subsystems are in robot. So if you need them anywhere, you just do robot.intake, and now you have the instance of the intake, and you can, robot.intake.setMotor, and you can tell the intake motor to go whatever speed you want. It used to be robotcontainer.setMotor.intake.setMotor. It also meant that you had to type container all the time, and its robot container is rather long. Autocomplete works most of the time, but not always. And because the robot file existed, you also had to like get all the way to robot C before you could just hit tab and do autocomplete. All of these are slight annoyances. Probably don't annoy everybody. They annoyed me enough to want to fix it. and just that file was getting really long and complicated. Robot was complicated too. Robot was always kind of complicated. It still is a little complicated, but we shouldn't have to edit it as often because most of it's set up, and once it's set up once, it just should kind of work. There are some things in here we still do. So like the robot init is anything that has to run at the beginning when we turn the robot on once. So like every once in a while we'll have to add something in here, but most of the time these are calls out to some of these other files, other classes, and we'll add what actually needs to be changed often into those files and not directly into here. So we're not doing things in here all that often. And then the other big part of robot container was what they call configure button bindings. And so that was where all of those button presses were for both controllers. And we like the only way to separate them, we just have them like in comments. So this was like driver controls, and then yeah, I don't even know. Operator just kind of exists. Operator just like starts right here, and we didn't even have comments for it, so you just had to be able to tell based on the controller. And all of these lines were getting really long and hard to read. They're still not perfect in the new one, but they're a little bit better. So we can see what it looks like in the new one. So now we have this Gamepads class. And Gamepads is where we put everything that has to do with the driver controls, operator controls, all of that.
Yeah.
And so part of that, and the hope for that, is that we're going to be able to configure them a little bit better. Oh yeah, that needs to just go away. That was test code. That's gone. So we can individualize some of the inputs. So there was part of the issue I know. Where was I going with this? So some of like the stick response and how quick they are to move the robot around. Some of those things. So I was trying to figure out the best way to be able to edit those nicely into like the dashboard and things, so we can change some of the dead zone feels, like when does it start actually responding, how much do you have to move the stick before the robot will start moving, what's the curve of that graph, so we can do like we can make exponential functions map to it instead, so it'll be more sensitive at the low end. So as you move the joystick, it gives you a lot of control over like the slow speeds of the robot, but then as you get closer to the end of the travel of the joystick, of the thumbstick, it just goes really fast, which is what you basically want, right? Most of the time you don't care the difference between like 85% of max speed and 90% of max speed. You just want to be going fast, but it matters a lot probably at like the difference between 15% of max speed and 10% of max speed. Those are two pretty drastically different things on the robot, and like noticeable. You'll see them a lot more. You probably don't even really notice that much of that 5% difference in 85 to 90. So that's one of the reasons why you can do it exponentially. And so we can change even like what that curve is. So we can do like, we can do x squared, we can do x to the 20th. You can put in whatever numbers you want. So some of that's based on some other team's code that I built into some of the stuff we were doing, because we can copy it. This whole class was based on code from 4141 that I found on GitHub. I've modified it heavily. It doesn't probably even look like their stuff anymore, but some of it is similar. So a lot of this allows us to bind the controllers at the right time too. So that was one of the other issues, was it used to just immediately bind every button, even if you didn't have like the operator controller plugged in. The code was expecting you to, and it would just throw errors all the time. It couldn't check for all the operator controls, like the operator joysticks and buttons and everything. And that was super annoying. So now this code waits and checks if there's a controller connected before it does it like adds all the commands to the buttons. So basically, if you don't have a controller connected, it just like nothing's happening. It's not looking for it. As soon as you connect it, it pulls it up and adds all the buttons correctly and lets you, run the intake and everything else you need to do, or driver. So we can actually test stuff on the robot. Like we can test Auton without plugging a joystick in, which you used to not really be able to do, because if you did, you would just have all of these error messages flooding the terminal window all the time, because it was just like asking for joysticks and didn't have it, even though you didn't need it because you were doing Auton testing. So that's just like a quality of life feature that is convenient. but then all of the driver bindings are in here and definitely look a little bit nicer than they did before. So like the lines got shorter than how crazy long they were in this old version, right? Like there's just a lot more characters in what we were doing last year than the setup this year. So it's a little bit easier to like read and understand what's happening. Operator.select button while held means feed balls. Easy enough to kind of read and see what that means without having nearly as many characters as the other one did, and it was just like filling the screen and the lines got really long. There's separate ones now for driver and operator. There's a different version, so I haven't implemented this yet, but the classes are here, or the methods are here for it. So we can there's a test mode in the driver station, and we had used it somewhat well in 2019, but not as well as I would have liked. In this next version, we'll be able to have certain methods, and like we can have a different button map for when we select test mode. So then we can have specific things that only work on the robot when we're in that mode, and we can check if all the functions and features of the robot are working properly.
Okay, that actually
in
sounds
test
pretty cool.
mode. Yeah, which is a lot of it is also to figure out how do we make it to where the robot, how can we make sure the robot's working properly better than we had before? Like all those little fixes. I mean, a couple of you are at Texas Cup, and you know how any little thing breaking is super annoying. So if we can find it in the pits, if we can find it, during lunch, whatever, and when we do these like test things, it's going to be a lot easier than if we let it keep failing until it actually breaks, just because something got, a screw got loose, something got messed up, a wire got loose, something like that, that we don't notice is broken until it gets on the field and it makes us lose a match. So hopefully we can get some of that test code working. Some of the other things I'm about to talk about will help with that too. So that was one of our big changes, that we have this gamepads thing that I think is going to make writing the control layout a lot nicer than it was before.
How do you like code the joysticks? Because like I saw like some of
so
it.
buttons are always in here. So buttons, you only have to tell it, the system, once you tell it a button is linked to a command, it only needs to get it automatically is checking for that over and over again once you tell it that. The joysticks you need to put directly in their commands, so those are in wherever you're using them. So I can show you an example. So in a command, something like the that's not actually even in the command. That was okay. The one I was looking for actually isn't here because we did a different thing and I don't want to go there yet. So swerve will work. So teleop swerve is like swerve for when we're driving, right? And we're just driving normally. So in its execute, so in any time the teleop swerve command is running, this method execute is being called over and over again, a loop, about 20 times a second. Everything is getting called. And in here, we're getting the y-axis that we're using. So we're getting driver.leftstick.getY. The x-axis, so those are both of our translate controls. And then currently we do twist on the triggers. We could look at swapping that if we want. So we could move twist to the right stick if we wanted to. With gamepads now, it's actually relatively easy to potentially have them swap in different modes. So there's a couple things I want to add to gamepads so it can know which control mode we're in. So we can swap it like from the shuffleboard, and we can swap entire control features and stuff. So we could have a different control set based on what we're testing and things. Mostly just for testing and for demos and stuff, not for actual competition. We would never want to be swapping control modes during a match. That would be bad. But there are times where it'd be cool. So it's one of the things I want to work on, is trying to get that to work a little bit better. But either way, even if we just had to come in here and edit it, it's a single line to edit, which isn't too bad. So yeah, so that's how joysticks work, and that's the same in anywhere else. You just call them from gamepads, driver or operator, and then whichever stick or triggers you're looking for. Okay, so yeah, so we talked about gamepads. We talked about moving things out of robot container. One of the other big things that I've been playing with over the last week or so is this folder called Telemetry. So what we haven't done well in the past is we haven't had a lot of good ways to get feedback and logging done well from our system so that we can actually see on the display what's happening at any given time. Like we have the driver station shuffleboard and stuff, and we had values coming back and forth, but it was always kind of like disorganized, and you have to like hunt for the value you wanted, and you like if you could find the 1 or 2 values you wanted, it was fine, but it always took a little bit of time because they would just like pop up wherever, and none of it was organized. And so I've known for a while that you could do this, but we never sat down and did it. So one of the things Shuffleboard lets you do, so I still have the simulator still running, so this program's still running. Shuffleboard will let you in software define how some of their little tiles are going to show up and like show you information. So in this telemetry class, we have the shuffleboard folder, and these are generating shuffleboard tabs and like deciding what information goes on them. So if I start up shuffleboard, start tool, shuffleboard. I can't scoot that over. It will. We can see we have the normal smart dashboard tab, and this is where you have kind of a, just kind of everywhere. You don't really know what's what. This is just stuff we're sending right now back still over smart dashboard because I haven't cleaned it out and gotten rid of some of these things. It's hard to tell what they are because they have like weird like lines in front of them. It's just sort of weird to see what's what. We have these new yellow tabs, and so all of these are assigned and are kind of built in our code. So we lay them out how we want. And so then certain parts of them, I don't know why that's not flashing, but I might have broke it at some point. But we can see certain different things. So like climber motor and stuff are, we're able to like see the outputs here, and you have this climber motor kind of layout, and then you can get the output percentage, -1 to 1. You can get how much current's going to the motor. You can get the velocity from the encoder on it, the position from the encoder on it, for any of those things if you wanted to. For swerve, we can do that for all of the modules. And then we also started playing with a way to do some of the tuning. I don't know if we're going to actually use this, but I put some work into making this work. So you can like change all the PID values and a bunch of the other things that allow the system to actually respond the way we expect. And like all the little settings you can do for each motor, you can just tweak them right here. And then you can decide if they're persistent or not, which basically means if I tweak them, are they going to stay when I reboot, or is it just something I want to experiment with? If I make them not persistent, you can play with them, and then on reboot, it's going to go back to whatever the defaults are. So that's kind of cool that works. I think there's going to be another way to play with tuning. Hopefully it'll be easier, but we'll see. That might be a thing. Intake, you can do the same thing. So all of these are just like samples. Most of these we probably wouldn't have. A lot of this stuff we'd put on main. So we'd have like the one main screen that we can see most of the status of the robot that we need. Some of these we might not need. Like if you have the intake motor, we probably don't need a position for the intake motor. We don't care how many times the intake has spun around. So we probably wouldn't display this, and we figure out how to remove it. Shuffleboard is kind of nice if you do want to just see a graph of something. We could take, oh, maybe you can. Why did it decide to be weird? Okay, well, Shuffleboard decided to not be nice today. Normally it's nice, and I can just take this out, but I guess you can take output percentage. Nope. I can take supply current. Okay, that's weird that it wouldn't let me take velocity though. But you can go in here and you can change this to a graph if you want, and so then this would graph supply current, which is cool. I'm a little weird why it's a little weird why it didn't let me do what I just tried to do, but it's fine. Yeah, now it's being very, very odd. Oh well, the shuffleboard's a little odd. It's not perfect. Here's where all like the gamepad tuning stuff. So if we wanted to change how the gamepad reacts or how the drivetrain reacts to the gamepad's movements, we can change each of the different deadbands, the exponential values, the scalars. So if we wanted to like make it, say we wanted to make like the top speed max out, so we could take the driver's left joystick scalar, and instead of allowing it to go to full speed, if we just type 0.75 in here, now the max speed of the robot in the forward and backwards direction is only going to be 0.75, so like 3/4 speed. So we could do that really fast if we wanted to. For like a demo, maybe we're like, ooh, we want to let somebody else drive, but we don't want them to drive very fast. You could tell them they could only drive 0.3 speed as the max. You do it to the X too, so they couldn't drive fast sideways. So that's things you could do really quickly that allow it to just kind of adjust how the robot's controlling. So those are things that are the driver could learn to tweak on their own to get the robot set up the way they're the most comfortable with. So once we establish who the driver is, they don't necessarily have to go in and learn how to change the program to make it more comfortable for them. They can tweak some of these settings directly, and it'll grow, and they can play with things a lot easier, and they have a little bit more control of the robot. Ideally, they should still be talking to the programmer about it, because we do want to get these, whatever their eventual defaults are, we want to get them locked into code in case you can wipe the ones that are just set on the robot, and you'd lose them forever, which would be bad if they got it dialed in exactly the way they wanted, and then we change a RoboRio or something, and then they're not there anymore. That wouldn't be good. So you definitely want to make sure they're communicating, but they can definitely do a lot of the adjustments themselves as they're trying to find the right way to do it. Tower has some of the same things as the same box. If we look at how we do some of this in code, the nice thing is a lot of it's repeatable. So like if we make one of those once, it's relatively easy to make them again. So what does it look like? So we have some things up in our library. We haven't really talked about this. So kind of the way we split up the code is we have a lib folder, and a robot folder. Roughly the concept is anything that's living in our lib folder is stuff that we should be able to take and put on a different robot. So if we're making the 2022 competition robot, lib should be identical to what's in here, basically. Or we should be able to transfer them back and forth very quickly. There shouldn't be any robot-specific stuff in here. So some of it exists. There's a swerve folder, but that's any swerve, not any specific swerve, right? It's stuff that just is useful to swerve in general. But it doesn't have any specific settings for like how to communicate to any of the motors on the robot. It doesn't know the subsystem names. It doesn't know any of that stuff. So all of that is in here. So some of those things are in telemetry now that we wrote. We have like a Falcon config layout. So this is figuring out how to set all the PID values, some of the other ramp rates and things that you can tweak in the Falcon to make the motor behave a little bit differently, make the system behave a little bit differently. And so we can play with those and tweak them on the dashboard really easily before we get the final settings right. So we shouldn't have to like do a lot of custom code to bring up a system, tweak the values the way we want it, then we can lock those in code and remove any of the stuff off dashboard if we don't want to be able to tweak it anymore that way. And so it's relatively easy. This is written one time as Falcon config layout, and then we can just use it in any of those tabs that we had. So like we had telemetry, I think tower had one, right? So yeah, tower is just using this Falcon or this tower front config is a Falcon config layout, and it's using all of that stuff we did in that other file. I forgot to double click. It's using all the stuff that's written here, which is convenient. There's a bunch of, this mostly works. There's probably some tweaks to do before this gets on the actual 2022 robot, but it's doable. There's some more little things in how we do some of the logging got a little bit different, and with logger, it's basically just like how we print out some of the statements we use, and we can show with like which subsystem has an error or something. That exists now, which we've kind of always had, but it's got like minorly tweaked. So we've had logger going back. I think it was started as like a code that 11.14 wrote a long time ago, and now we've changed it and modified it quite a bit to be our own thing. Most of the time, yeah, so we might be able to see. Most of the time we try to give credit and stuff. Yeah, so logger was 11.14 code at some point, 2015. So this is a long time ago. We've been using it and changing it. Yeah, in general, if anywhere in our code base, if you are using a class that some other team wrote, we normally try to put their number in it somewhere so people can know where we got the idea from, even if we end up heavily modifying it. We try to keep giving credit whenever we can. It's probably not perfect. We probably stole things or borrowed things from other teams in many places where we didn't give credit, but we try to. What was the other thing I wanted to talk about? There was like one more that I was like, oh yeah, it's cool. Backlogging. Helpers, driver, operator. Nope, none of those. There is another tool that we hadn't been using well. So another tool that we haven't been using well is called Glass. And so Glass looks like the simulator, but it's like the dashboard. So it has the same values that you can see in Shuffleboard over here, like the same table. And all of these are just the values that would be sending back and forth between the robot and the laptop. So we can see all of these on the driver station, right? So Glass is kind of cool because we have the same interface as the simulator, but we have access to all the values from Smart Dashboard when the robot's actually running. So if we wanted to graph some things, we could. So we could go in and is that not? So we could like see how the drive was working. We could add a plot. I can drag over drive Y, and if I come over to the simulator and tell it to enter autonomous mode, well, maybe not. Why did the simulator stop working? Or it won't work. Of course it won't work. Why would it not work? Why does it? It's connected, so it sees it's getting a rate, and plot should be getting drive Y. I thought drive Y should be moving. Maybe drive Y is not moving. Swerve. Drive Y. Oh, no, drive Y is not working for some other reason. Okay, so I broke something else that's stopping this from working. That's a whole different problem. It's also like not resetting when I reset autonomous mode. Okay, those are mostly working. Let me can delete that. We can go get one of these other ones. So what is working? Mod 0 wheel velocity is working. Okay, so we can pull like the wheel velocity here, put that in there, and now when I reset and go to autonomous, there we go. So now we can see it actually moving. So we could plot any of our any of the motion we want. So if we're trying to tune the control loops, like make the like we have a launcher in 2022 and we have a launcher wheel, and we're trying to spin it up to a certain speed, we could see if we tell it a certain set point, we could watch it go to that set point, see how well it gets there. And we can use this to tune all these values really easily, since we can also go in and type them in over here. You can have multiple things on the graph at the same time. So this wouldn't make much sense to do this because integrated angle is some like huge number. But in theory, you could do that. And then when I, oops, I didn't hear zoom. So yeah, so integrated angle is some massive number to where it doesn't. Yeah, there it goes.
So that's insignificant.
It's less useful because integrated angle is so high. But you can see integrated angle. You could actually see this also moving at the same time, but it would be really tricky. Yeah, you can see it's above 0 right now, whatever it's supposed to be. So yeah, there's ways to do it and make it work. And we can see the different responses mapped together. So this is just an easier way to go in and tune stuff. You can type in tuning values and tweak things and then run it off the dashboard or off the driver station and just enable the robot again and again and be tweaking values in here. And this is easier than trying to make it. I think it's going to be easier than trying to get sort of this tab working for every motor all the time. It depends, but it's also just easier to do the graphing because you can keep everything in the layout that's the same, in Glass because you can always be seeing it in this table, and most of the time you're only tweaking a few different things. And so that's not too bad. So we could be like, if we had drive mod 0 up, we could sit there and change the PID values for them, while also seeing the graph of the outputs and the error and everything else if we were showing those in here. So that's going to be pretty cool to be able to tune that way. I think that's going to work nicely. If not, we can do it this way. We can do it the old way. There's a couple other different tools that exist. There's like the really old Smart Dashboard tool, which we shouldn't use very often. Like we should almost never have this one open, called Smart Dashboard. We'll almost never use it. There is one thing that's useful on it. It has this robot preferences list that lets you load and save some of the preferences off. Hopefully they get this added to one of the other dashboards. Like they could add it to Glass, and that would be easier than having to load this one old program that exists. Most of the others we don't use too often. Outline Viewer is just that same kind of window that's in Glass already, so it just shows all the different things that are that we've sent back and forth from the robot. In WPILib, it's called network tables, is what it's called, because it's a big table of data that's sent back and forth over the network. And it's how the driver station and the robot communicate, and we can see all that data coming back and forth. So this isn't too useful either when we have Glass that just looks nicer and has all of the data there as well. So that should be cool. Does anybody have any questions about other stuff, even if it's stuff that isn't related to new things, or just like how some of the robot works, or any of the code? Some of the things I'm going to look at doing is constants is also another place where kind of like every system has stuff right now. So I'm probably going to look at breaking this off into individual constants classes for each subsystem, so then it's easier to have one person editing it and know that they're not having to do any of like the GitHub diff stuff, and we're not worried about someone accidentally changing something in a system because they just don't know what it does, and then it affects something else. Also, this file just ends up getting really long, so it's hard to find the thing you need sometimes in here. Like you can kind of search for it, but it's still not super easy. So hopefully we can make some of the configs of our systems and some of the settings a lot easier to get to and navigate when we need to. Because a lot of times they just sit and you don't actually touch these, and then eventually when you need to figure out where the setting is, it's sometimes hard to find the correct one. So I think if we break it out by subsystem, it should be a little easier. So there's probably going to be more files inside constants, just like there are for subsystems and there are for commands. We'll probably get a few more of the command files to make sense too for some of these. Because yeah, like ball path is here, but it's missing a bunch of the ball path ones, so they'll probably get moved up. We can actually do that now. So if you just, VS Code's pretty good. If you just move it, it'll ask you, do you want to move it? And then it'll ask you, do you want to do the refactoring so all the other files know where it's named? You hit OK. It opens up all the other files, it changes them, and then you can just save all, which is either file save all, or the keyboard shortcut's a little weird. You have to do Control K and then let go and then press S. Like it has this little thing down here that says Control K was pressed waiting for next thing. Then if you press S, it saves everything. So then so you can move stuff around a little bit easier, which is nice. So yeah, now feedballs is up there. If we do that, after we've changed a bunch of stuff, we can go in and commit things to the GitHub repo. So this is our source control. So we can type a message in here. A bunch of these aren't. A lot of this is just reorganization of things. I think a lot of these I just added, like, we didn't have 3847 at the top of some of the files, so I added that. Most of this is just reorganization. So that's fine. And then we can hit commit. Would you like to stage all the changes? Yes. So all of those got saved with Git, which we've talked about before, but we'll reiterate. Once you commit, you basically just save it locally as a version, but you don't push it to the internet necessarily, which can be really useful. So we can save versions even if we don't have internet access. So if we're at an event, we don't have Wi-Fi, we can still be saving versions of the code. And then when we get to Wi-Fi, or if we tether our phone or whatever, we can then sync the changes up to the GitHub server. The actual push commits to origin master, which is where it is right now. Or it would have if I was logged in on this thing, which I thought I was, but apparently I'm not. So I will do that later. So it's going to tell me it's mad at me now, which is fine. No, I don't know what it's doing. Okay. I thought I already did this, but I don't know why it switched things. It's being a little odd. Okay. When you have to sign into GitHub in VS Code, you end up logging in. You get this little authorization token, and then you have to come down here and hit that little button at the bottom. You can paste in that long string of text and hit enter, and it should work. There it goes. Okay, so then it committed the changes. So that's cool. The other thing that I have on here that I haven't talked about yet. So GitHub has a pilot program or a beta release of a thing called GitHub Copilot, which is basically a very, very smart autocomplete and like code suggestion tool. So it's not perfect for what we're doing all the time. It doesn't know necessarily things about the robot, but it does know a lot of. It can like figure out patterns for you in a lot of really nice ways. That's not where I want to be. Where do I want to be? I want to be in the tower telemetry class. So in here, say we hadn't written this yet, and we were coming in, and okay, so we write this one, and we also want to have the tower rear. If I hit enter, of course it decides not to do it today. Oh, there it goes. So that grayed out text, that's GitHub Copilot basically telling me, hey, is update what you want? I think you want update. And so if that's what I want, which oftentimes it is, I can just hit tab, which that isn't that big of a deal. That's kind of what the normal autocomplete kind of does for us anyway. But it'll get even smarter sometimes to where you're not even, sometimes it doesn't work, but you can just like, it's suggesting that I want to make that comment there. So it'll suggest comments for you. It will suggest other things. So if I type public, it suggests a whole like method for me. I don't want to write that. That's not what I want to write, but I don't actually know what I want to write, so it doesn't know what I want to write either. But a lot of times, if there's something you do want to type in, it'll do the suggestions really quickly for you over and over again, which is kind of cool. In here's a cool one I can do. So all of these KP values and all of this exists. And so when I was creating that, I can do config.slot 0 .kp, and so it will help me autocomplete that. But now when I hit enter, why did I do it? There it goes. It took a bit, but now it's saying, okay, it's suggesting I want the next line to be KI, correct. Next line to be KD, correct. Next line to be KF, correct. Is it gonna get the? Oh, that is the last one because I already have iZone below it. So it even know where to stop when I didn't even know where to stop. So it rewrote that code that I had just deleted, basically because I just wrote the first one and it knew from all of these values up here what I was looking for basically already, and from the from what slot 0 is, right? So it looks at what slot 0 is, it looks at what's in this what's in a slot configuration, so it knows it has a KP, KI, KD, and a KF, so it just suggests going down them for me automatically, which is pretty cool. So there's a lot of like, it's just a nicer autocomplete. It solves a lot of stuff. My spelling's really bad. It helps with that a ton. Because I can just be like, that is exactly what I want. GitHub, thank you, and hit tab, and I'm done. And so it's just a big convenience feature. So hopefully we'll be able to sign up for that. Ooh, that was front. That should be rear. Sometimes it gets, or I get it wrong, or it gets it wrong. So yeah, so you can sign up for that on GitHub. You can look up Github Copilot, and you can put your GitHub username in, and you have to like wait to be activated. It was pretty fast for me. I think it activated mine in like 3 to 4 days. It was like, hey, you can be part of the beta. So I think they're rolling it out to more people now. When it first came out, it was definitely pretty limited, but it's been a couple weeks now that it exists. And it seems to work pretty well with all the new FRC libraries and everything. I haven't run into any crazy issues with it. It's definitely not going to write everything. It's not just going to magically code stuff for you, but it gives you a decent idea of what your next line you want it to be. Like sometimes it'll suggest whole function, sometimes it'll suggest comments, which is kind of cool. Let's see if it does it. Yeah, so like right there, it's like, hey, do you want to comment create the tab? That's a pretty good comment for that line. That's what that line does. It creates the tab.
Wow.
So like it does a bunch of stuff based on context. It's kind of like the Gmail autocomplete stuff that Google does if you've used that, where it like
Right.
suggests whole sentences and stuff for you. It's pretty good. It's not bad. Like the fact that it comments for you is pretty awesome. It's definitely not perfect, but it's a helpful tool. If it gets you so you are literally typing slightly less, which is not a bad thing. You definitely have to double check what it's doing because it's definitely been wrong. But that's not too terrible since we can also just simulate, and if it's not working in the simulator, we can figure out what happened. Like you can go back and check what broke or what did you take a suggestion that wasn't correct, that sort of thing.
Right.
Okay, I think that's most of what I wanted to go over tonight. Any other questions? Cool.